So we will be looking at graphing linear equations. And specifically then, what is a linear equation? Well, it's an equation whose graph forms a straight line, and linear equations are usually shown on a coordinate plane. And we can go back and kind of remember, what is a coordinate plane? And in fact, I can bring that up for you here. This is a coordinate plane. It's now the background of this. But if we remember in terms of a coordinate plane then, we have the x-axis and the y-axis. And you can see there's our x-axis. Let me change colors to get a nice strong color going on. Here's our x-axis and here's our y-axis. So this is the coordinate plane that we'll be graphing straight lines on, linear equations. And at the end today, we're going to look at how linear equations can model real-world situations. Some that I have modeled are payments on cell phone plans or loans that you might have taken out. They're going to be simple linear equations, but still the idea is that we can model real-world examples. So I'm going to start off, as I like to, with a polling question, and let me set that up here. Okay, so polling question, and we're going to look at question number 1 first. This has to do with the idea of slope, okay? So if you want to go downhill skiing, which slope of a hill would be, oops, must not have saved my most recent version, would be best, okay? A, B, C, or D here. So if we want to go downhill skiing, what kind of slope would you want to go downhill skiing on? And go ahead and poll them. And the polling, for those of you who haven't used that before, if you look above, right under it should say my name, Maggie, as moderator. You see a smiley face, a person with a clock, a hand, and then an A. And if you click on that A, and you will see that you can choose choice A, B, C, D in there. Okay. So again, we're doing question number 1 with a poll right now. We want to go downhill skiing. And so we're thinking about slope. What does slope mean to you? What have you heard about slope before? And which one is going to be best for downhill skiing? I'll give you another 15 seconds to think. Ah, we have some people knowing a little bit more about slope. Okay. Okay, I'm going to post. Not everyone has polled in, but we'll post what we can have here. Those of you who polled in, many of you said A, that the slope of -2/5 would be best. Someone was looking at B, a slope of 1/7, and a bunch of people either weren't curious or not sure what the polling feature is. But I would agree a slope of A. So the idea here is we're going downhill skiing. I can draw a little hill in here. Here's my hill. Okay? And if I'm going to go skiing on this hill, I want to make sure that I am descending, right? I'm going downhill, which means that I want a negative slope. So A gives us a negative slope. And we're going to talk more about what this means. I'm just kind of curious what you know right now. So kind of with the idea, so if I have a negative slope of 2/5, what that is saying with rise over run, what someone was giving us, is that for every 2 units I go down, 1, 2, maybe that's 2 feet, I'm moving 5 units. I'm running horizontally 5 units. But with that in mind now, let's look at question number 2. And now we want to think, if I'm taking a leisurely walk in the woods now, note the word leisurely. Okay, I want to take a leisurely hike in the woods. What slope would be best situated for that walk? Okay, question number 2 now. Go ahead and poll again. We're looking at a leisurely walk in the woods. Okay, what slope might be best for this leisurely walk in the woods? All right, most of you have pulled in, so I am going to publish our responses so we can talk about this one. Okay. Bring that down so we can see our other ones. So now with the leisurely walk in the woods, most of you went with B. Someone was looking at C and still a couple people unsure. And I also would go with the idea of B for this question. And again, if we're thinking of rise over run, 1-7, I leisurely walk in the woods, I probably don't want a very steep slope, right? So what this is kind of telling me is that for every 1 unit that I go up, I would be running 7 units, okay? Why would 8/3 not be very good? Well, that would be a pretty steep slope, okay? 8/3 would be a pretty steep slope. That means for every 8 units I go up, okay, I would be going 3 units. That might not be so leisurely, and we'll talk later about what undefined means. But yeah, a leisurely walk is probably going to be this more gentler slope of 1/7. So this is just kind of an overview of slope in terms of a more conceptual way. Let's take a look at it in more of a mathematical way then. So slope is a ratio. And we've looked at ratios, and it's the ratio of the vertical change to the horizontal change, or what most people remember as rise over run. Okay, and so slope in the linear equations shows if the line is ascending, if it's positive, or if it's descending. So descending, negative, that would have been like our ski hill, right? We want to make sure when we're downhill skiing that we have a descending slope, okay? You know, versus our line that's ascending, that's this picture right here, it's positive. And so when we look at this idea of rise over run, we're looking at how many units we move vertically, okay? And you can see this vertical unit change, okay, I've given right here. It might be kind of hard to see, but hopefully you see that I start here at 0, okay? Now if I want to look at this vertical change, how many units have I risen? Okay, go ahead and type in, how many units have I risen up? Great, thanks Wendy, 10 units, okay? Because I started here at 0, and I went all the way up 10 units. So my rise in this case is 10. And if slope is rise over run, then I need to look for my run. This might be a little harder, but I think I have it here at 3. And I'm trying to get you to stop at this point. So can anyone figure out how many units I have run? What my horizontal change is? Okay, James gave me 5, and I think this is harder to see, 6. Yeah, I was trying to get you to 6. Again, the difference is I started here at a 3, and I went over to 9, so 6 units. So visually, by picking out 2 units on this line, we can see that we have a rise of 10 units, a run of 6 units, which means that is our slope. However, we'd probably want to reduce this into its smallest improper fraction, which would mean 5 over 3 would be our slope. And what that means is I also could have risen 5 units, which would be here, and gone 3 units and should find another point. 1, 2, 3. Yep. Okay, so 5 over 3, 5 over 3, or, like I said, 10 over 6. And we know from ratios that these ratios are the same. So that's a visual picture of slope, at least an ascending slope. We can also find slope by using a formula. Okay? Slope is rise over run, as we've talked about. But what that means is if I was given 2 points, if in that previous example I'd actually said, here are the 2 points, we can use the idea of the change in y divided by the change in x. That change in y is that amount of the vertical change divided by the change in x. Now, these 2 formulas look very similar. The difference is in this first formula, I start with my y2 variable, which means I have to start with my x2 variable. So let me give you a little bit more idea of what that's looking like. If I called these 2 points x1, y1, then I called this next point x2, y2. What this is saying is that in the first equation here, the first form of slope, if I start with my y2 variable and subtract my y1 variable, then in the denominator, I need to start that same way. I need to start with my x2 variable and subtract x1. And the second equation says you could also say I'm going to start with y1 and subtract y2, then have x1 and subtract x2. As long as, again, whichever point coordinate you start with it, you start with the same y variable, you start with that same x variable in that point. So now with these 2 points, why don't you go ahead and calculate the slope. Go ahead, see if you can't calculate the slope here. Good. A couple people have pulled in with -3/2. So let's see where they're getting at. I've also plotted this because we'll look at the slope and why it's negative in this case. Calculating it using our formula, and I will use the I'll use this first one where I start with y2. I would have -2 minus 7. That's my y2 minus y1. Divided by, now I have to make sure that I use the 1, the x2, minus a -5. -2 minus 7 is a -9. And 1 minus -5 means I'll be adding, which is 6. So a -9 divided by 6 does reduce to a -3/2. Okay? And so I have plotted the 2 points, -5, 7, and 1, -2. And I just kind of want to talk about then the idea of a negative slope. So we consider slope rise over run. And why this is negative is first, if I connected the line here, which I'm going to draw in with a feature because my line drawing wouldn't be perfect. Okay. If we connected this line, you can see that we have that descending slope, right, that negative slope. And the reason is because my rise in this case is actually a fall, right? It's actually a negative. I've gone down 9 units and I've gone over 6 units. Okay, so we need to make sure that we consider rise over run. A rise could also be a negative, right? A rise could also go negative in which case we have to consider that then our negative slope or a descending slope. Okay, very good. So that's a little bit more about slope. Before we move on, does anyone have questions about slope? Very important key piece to lines. Okay, if you do, you can just chat your question in, or at any point when I'm working or talking, feel free to raise your hand. Again, using the smiley emoticon, you can, give me some emotion, or you can go to the third button, which actually is raise your hand. No? Okay, I see maybe one person's typing in a question. Yes, James's question is, I used y2 minus y1. Yes. You can see that negative 2 is the y2, and 7 is the y1, and notice that it is subtraction. So I did use that. If I did it the other way, which I can show real quickly, we'll pick a different color, I would get the same thing. So if I went with y1, saying 7, I would have 7 minus a negative 2 divided by 1 minus, oops, nope, we got to make sure I start with 7, which means I have to start with negative 5. Negative 5 minus 1. Okay, got to be very careful about these. So 7 minus a negative 2 is 9. Negative 5 minus 1 is a negative 6. And then we can see this still does reduce to negative 3 over 2. Okay, so either way, like I almost did, it's very important that whichever y variable you start with, you choose the same x variable to start with in the denominator. Does that clarify your question? Okay, why not 3 over a negative 2? And this is really more of just like a mathematical semantics. When we write things with negatives, so 3 divided by a negative 2, it's not incorrect, but in mathematics more formally, we almost always write the negative either in the numerator if we have a fraction, or completely out front of that fraction. And that's honestly just a mathematical semantics. It's just a way we like things. That's all. So we would write that as negative 3 over 2 or a negative 3 halves. But 3 divided by a negative 2, not wrong, just not how we write it in mathematics. I guess that's the best explanation I can give you. Okay? Good. Nice clarifying questions. We will move on now. Talking a little bit about the forms that lines are written in. Now, I have two forms that I'm going to talk about, and I'm using these two because they're the most commonly used. There are other types of forms of lines. I recognize that, but in this instance, I'm going to look at two main forms. The form most commonly used is probably slope-intercept form, y equals mx plus b. And this is the form where m is our slope and b is our y-intercept. Okay, so we've been talking about slope. We'll talk a little bit more about y-intercept. The other form used often is called standard form. That's given by ax plus by equals c. And in this case, different than slope-intercept, a, b, and c has to be integers. Okay, there's no fractions. And so because there's no fractions, we're going to have to sometimes use some algebraic manipulations to make sure that we eliminate some fractions. The other thing about standard form is a is always given as a positive integer. Again, this will maybe cause some specific algebra manipulations that we need to create. I most often use slope-intercept form, but I'd like to introduce you all to both of these forms. So slope-intercept form, y equals mx plus b, it really makes it easy to graph and to figure things out because the slope is given to you. 3/4 x means I have a slope of 3/4, a rise of 3, and a run of 4. Okay? Then it's given to me the y-intercept, b. 3 is the y-intercept, and the y-intercept is the point, excuse me, let me grab a drink of water here. Okay, the y-intercept is the point where the line crosses the y-axis. Okay, so if we think back to our coordinate plane here, we have our x-axis and our y-axis. So in slope-intercept form, 3 is the y-intercept, which means I cross the y-axis at the point 0, 3. Okay, 0 because that's how many x units I'm moving, up 3. Okay, so that is the y-intercept. So now if we look at graphing these equations when it's given to us in slope-intercept form, it's very nice. How I graph these is I start with the y-intercept, or our b value. And in this equation, b equals a -1, so I've placed a point at 0, -1. And that's that point right here. Okay, then I use my slope, in this case 1/2, to rise 1 unit and run 2 units horizontally. And then put another point down. And I can keep using this same idea. Rise 1 unit, run 2 units. Rise 1 unit, run 2 units. And when I'm ready then, you need at least 2 points to graph a line. You can have more. But once I'm ready, I can plot that line. And because lines continue on in both directions, we usually draw arrows at the end to say that this line can continue on and on and on upward in a positive direction and continue downwards in a negative direction. But that's the nice part about graphing these things in y equals mx plus b, or slope-intercept form, because that slope and that intercept is given to you. Okay, very nice in terms of graphing. Another way we could look at graphing something, and again, this is slope-intercept, but I want to bring it up because it's going to help us later on when we model equations, is to use a t-chart. And t-chart gets its name because we usually kind of draw in a t. What this is telling me is choose an x point, substitute it in, and find what the y point is. So if I choose 0, 0 is always my first point I like to choose. Then I would have y equals -2 times 0 plus 1. And -2 times 0 is 0, plus 1 is 1. So my corresponding point for y then is 1. And we know 0, 1 is a point because that is our y-intercept. But I could choose another point to help me. I could graph 1, and this will now be y equals -2 times 1 plus 1. -2 times 1 is a -2, plus 1 is a -1. So the point 1, -1 is on my graph. And I can continue this. I usually like to look at points on either side of 0, -1, so I would have y equals -2 times a -1 plus 1. Negative 2 times a negative 1 is a positive 2, plus 1 is 3. So now my xy is negative 1, 3. This is giving me, again, a picture of what I want my line to look like. So, didn't connect that perfectly, but there's my line. And making sure that this moves on to infinity, I draw on my arrows. So a T-chart is a really handy way to help with graphing. Okay, so sometimes we're not going to give you the line. Sometimes we're going to ask you to find an equation of a line. Okay, and I want to practice a lot of pieces here. So given this slope, negative 3/4, and the point 2, negative 1, find the equation of the line in slope-intercept form. We're going to start with that. Then we're going to work on writing it in standard form so we can recognize what standard form looks like. So I'm curious to hear your thoughts. We're given a slope, we're given a point. How do we want to start this equation? How do we want to start by finding the equation of the line? I saw someone had some ideas. Feel free to put them out there. And this is for us to learn and grow together. How can we start this? What form of an equation maybe are we looking at? Good. So a couple people have said we're looking at maybe using y equals mx plus b. And that's what I would use because we're looking for slope-intercept. So we're going to start with y equals mx plus b. And then someone says, hey, but I recognize negative 3/4 is my slope. So I'm going to plug that in, but we need to make sure that we're plugging that in just for the m. Okay, so we have y equals then a negative 3/4 x plus b. This is telling me now that I have a slope of negative 3/4. What I'm missing is what is my b value? Okay, and that's the trickier part of this. What is my b value? Well, how can we find a b value? We still have variables of y, x, and b. What can we do now with the information that's given? Good. You see that we have this point here, and this point is an x, y. All right? So this x value then of 2 can get substituted in for where I have that x value, and the y value of negative 1 will get substituted in. So I'll have negative 1 equals negative 3/4 times 2 plus b. Okay, and now we'll be able to find our b value. Okay, so a negative 1 equals negative 3/4 times 2. Well, a negative 3/4 times 2 is going to be actually a negative 3/2 plus b. Then I would need to add 3/2 to both sides. And in adding 3/2, negative 1 plus 3/2, well, I could consider negative 1 negative 2 over 2. Okay, so negative 2 over 2 plus 3 over 2 is 1/2. B equals 1/2. So now that I know what B, my y-intercept is, I can bring that back up to my original to say that slope-intercept form then, the general equation of my line is y equals a negative 3/4 x, there's my slope, plus 1/2, my b value. Okay, so this is slope-intercept. Well, now that we've gotten in slope-intercept, the next thing this question is asking us is how do we then write this in standard form? Remember, standard form is ax plus by equals c. And we want a, b, and c to be integers and a to be positive. So what are your thoughts? What are we going to need to do to make sure, first of all, that we have these in integers? Okay. What do you want to start with? Excellent. We want to multiply by a common denominator. And what would that common denominator be? Good. So that means we need to multiply this whole equation by 4. Okay? In doing so, I have 4y equals a negative 3x plus 2. And now I can move this into standard form by adding 3x to both sides. And I find that I have 3x plus 4y equals 2. And that would be standard form because a, b, and c, 3, 4, and 2 are all integers, and 3 is positive. Our leading integer, leading coefficient is positive. Very good. All right, moving on, we're going to discuss horizontal and vertical lines. Okay, so horizontal lines. I'll draw a horizontal line in so that we're able to talk about it here. Okay, let's say I give you this horizontal line. I have to put my arrows on there. And we're trying to figure out, well, what is the slope? Here's where we should not only find the slope, we should also find the equation. Okay? And the equation will help us also with the slope. So first we're going to look at the equation, then we'll look at the slope. Well, a t-chart can help us here. Okay? If I choose an x point, let's say I choose 0, my corresponding y value is 2. Let's say I choose x is 1, my y value is 2. And keep going, I can choose a -1 and my y value is 2. I could choose 100 and my y value will probably be 2. So looking at this, I can see that y is always 2. No matter what, y is always 2. Okay? But now let's figure out what our slope is for a horizontal line. Slope, again, we can look at that as rise over run. So I could take some points that I've plotted here and look at the change in y over the change in x, or my rise over my run. I'm just going to circle 2 points here so that we can see what our slope is going to be. First, I look at my rise. What is my rise? Go ahead and type in. What is the rise between these 2 points? Good, we have a rise of 0. And what is my run between these 2 points? 2. So my slope here is 0. 0 divided by 2 is 0. And again, I could choose any points on here. And I'd see that I'd have a rise of 0 and a run. Well, it's not going to really truly matter because my run could be 2, it could be 7, but 0 divided by that will be 0. Okay? So now conversely, let's take a look at a vertical line. Okay? So I'm going to draw a vertical line in over here. There we go. There's my vertical line. Okay, choose different, try to get my greens. There we go. Match them up here. So, what is the equation of my vertical line? All right, again, if you want, you could T-chart this thing. Let's look at the equation. I have an x value of 3, so 3, 0, 3, 1, 3, negative 2. What I'll notice is that x always equals 3. Okay, but now I want to check on my slope. All right, and I will pick 2 points and we'll again look at slope. I will choose this point here and this point right up here. Made it real nice and big so you can see it. What is my rise between these 2 points? What is the rise between the 2 points? 3. Okay, we've moved up vertically 3 units. And the run then is 0. Excellent. And so we have this divide by 0, 3 divided by 0. And in mathematics, we know we cannot divide anything by 0. And so this slope is what we call undefined. Okay? We cannot define this slope. No, that is different than saying no slope. No slope is actually 0 slope. Okay? A horizontal line actually has no slope. A vertical line is undefined. Okay? We cannot define the slope of a vertical line. So now parallel and perpendicular lines. And we have a little bit of a fill-in-the-blank game here. We'll start with parallel lines. And I can draw in some parallel lines here. Okay? We'll look at a parallel line like this. And another parallel line, a line making it parallel, looks like this. There's a set of parallel lines. And what can you notice about it? Parallel lines have the blank slope. Fill in the blank. Great, they have the same slope. Parallel lines have exactly the same slope. Okay, and if we wanted to calculate that slope, we could choose 2 points and find the slope. Here's 2 points. I have a rise of 2 and a run of 1. So my slope here is 2. And I can see that in this other one. If I start at 0, 0 and go out to 1, 2, then I have a rise of 2 and a run of 1. Okay. Now I'm just going to clear this off a little bit. So we can maybe look at a perpendicular. Okay. I'm going to draw in the perpendicular line then, a line that's perpendicular to this. Okay. There's a line that is perpendicular. Move it so it crosses there. Okay, so perpendicular lines. Now, perpendicular lines, let's take a look at the slope. Perpendicular lines form a 90-degree angle. Okay, that's one thing about perpendicular lines is they have a 90-degree angle. And if we look at the slope of this one, okay, so our first slope, our line has a slope of 2. The slope of this one has a slope. Okay, so our first line has a slope of 2. Our next slope has a slope of a negative 1/2. Okay, we want to consider a rise or fall of 1 and a run of 2. So then what do we think about the slopes? How are we going to say what the slopes of perpendicular lines have? How can we define that? Might be helpful, I could even look at this as 2 over 1. Anyone know how we define that, the slope of perpendicular lines? Okay, good. They're definitely opposites. And how are they opposites? What's opposite about them? Good, good. Negative and flipped. Perfect. So when we say flipped, what we're really talking about is the word reciprocal. Okay? We're looking at the idea of a reciprocal in terms of 2 over 1. The reciprocal is 1/2. But then it's also negative, right? So perpendicular lines have a slope that is considered a negative reciprocal, which means one slope has to be positive, okay? One slope has to be negative in order to form that 90-degree angle, okay? So you have a positive slope and a negative slope, and the actual rise and run is a reciprocal. Excellent. Nice work. Negative reciprocal. Sometimes people say opposite reciprocal. Opposite meaning sign change. Okay, not the flipping part. Very good. So now, if we wanted to find the equation of a line that passes through the point 2, -4 and is perpendicular to the line 3x minus 2y equals 15. Well, we've got some work to do, okay? First, we have to look at, well, what is the slope of the line that's given to me? How about you all work and try to figure out what is the slope of the line given to me? It's given to me in standard form. So I might want to rewrite that somehow to try to figure out what is the slope of that line. Okay, lots of you out there, what is the slope of the line? Just this original line here, 3x minus 2y equals 15. Let's start by thinking, what form do I maybe want it in order to find the slope? Good, we're going to go back to our handy dandy y equals mx plus b. Yep, plus b. So I'm going to start with 3x minus 2y equals 15. And I'm going to put it in y equals mx plus b, or slope-intercept form, because that's going to tell me what the slope is. So I'm going to start by subtracting 3x on both sides. This leaves me with a negative 2y equals negative 3x plus 15. Next, I'm going to divide everything by a negative 2. So I have y equals 3/2 x. And I get 3/2 because a negative divided by a negative is a positive. 3/2 x minus, oops, sorry. Delete that. There we are. 3/2 x minus 15/2. Okay, so this is the slope. 3/2 is the slope of my original line. But now I want to find a line perpendicular to it. So if the slope is originally 3/2, then I sometimes could say this at the slope, and we use this kind of upside down T to mean perpendicular. What is the slope of the perpendicular line? Okay, what is the slope of the perpendicular line? Good, -2/3. That negative reciprocal, so the reciprocal is 2/3, and we take the negative of it. So now what I'm going to do is I'm going to say I have y equals -2/3 x plus b. I'm going back to slope-intercept form, saying I know I have a slope of -2/3, but now I also have a point. Okay, I also have a point, 2, -4. So similar to what we did before, we are going to substitute in this xy point. So I have a -4 equals -2/3 times 2, that's my x value, plus b. And I can solve for b now, which I'm dealing in fractions, but I know how to do that. -4 equals a -4/3 plus b. So I'm going to want everything in thirds now, so I'm going to change -4 to a -12/3 equals -4/3 plus b. And now I can add 4/3 to both sides to figure out that b equals -8/3. Okay? So if b equals a -8/3, last step then is to say that y equals, I'm going to go back to my original slope here of the perpendicular line, -2/3 x minus 8/3. And that would be the line in slope-intercept form. Then if we wanted to get it into standard form, we would have to do a little more mathematics, multiplying by that common denominator of 3 and adding x to both sides. Good. Well, I want to look at an application problem then before we're done today. So let's say that we're buying a laptop on layaway, and the laptop originally cost $1,100. I deposit $250, and then I decide I'm going to make weekly payments of $50. What I want to know is how many weeks it's going to take me to pay off my purchase. And we can actually model this situation using a linear equation. And what I might suggest is starting by creating a table to find some sort of pattern. Okay? So we're going to have some variables. We're not quite sure what it is, but this will kind of help us look at things. First of all, if I start off with something that costs $1,100, I pay $250 off right away, I'm left with $850. Okay, so I've made 0 payments other than my deposit, but I've made 0 payments of $50, and I owe $850. Okay, why don't you give me a thumbs up? That's kind of an interesting one. Give me a thumbs up if you go to the smiley face if you understood my first step here. Making sure I realize that I've paid off $250, I'm left with $850, I've made no payments so far. Give me a thumbs up. Good. Okay, good. We've got some people who are definitely following along then. Now what happens if I make one payment of $50? How much am I left with? After making one payment of $50, how much am I left? What do I still owe? $800. Okay. Well, then the next week, week 2, I make another $50 payment. And so now I'm down to $750. And I could continue this table Week 3, payment of $50, down to $700. I could continue this table, or I could look to model this as a linear equation. And I want to know what my variables are. So if you had to give a term for the variables, I put X and Y in there. The things that are changing each week, 0, 1, 2, 3, those were changing each week. So what might we call that X variable? What would you, if I had to say X equals in terms, give a definition of what that variable is. What do you think X equals? What could we name that variable? Any ideas? Well, we're running out of time. Oh, there's someone maybe thinking they have an idea there on now. Yeah, X is the number of payments, okay? We can even say the number of weekly payments. And then Y is going to be what I still owe, right? The amount of money that I still owe on my purchase. So if I wanted to now model this as an equation of what I owe, I could say what I owe is going to be $850, right? $850 is what I owe, but I'm going to take away from that $50 for every payment that I make. So you can see that here's $850. I subtract $50 for one payment. I've taken $850 and I've subtracted 2 times 50, or $100. And so on and so forth. So this is a way that we can model a linear equation. And the last part says, how many weeks will it take to pay off my purchase? Well, if I'm looking to pay off my purchase, I'm looking to make what I owe $0. And I don't want to owe anything left. So to solve this then, I would say, well, if I want this to be $0, then I have to find the number of weeks that that's going to take me. So I'd have $0 equals that $850 I owe minus 50 times how many weeks. And to solve this then, I would add 50x to both sides and set that equal to 850. Then I would divide by 50 to find out that x is going to equal 17 payments, or 17 weekly payments. And we want to make sure that we label. So I'm running off the edge there. Good. Okay, so that's what I have for you to introduce linear equations. We looked at slope, we looked at vertical, horizontal lines, parallel and perpendicular lines, how to find the equation of line, and how to use lines to model applications. So I thank you so much for joining me and for participating. I will stay on if you have any further questions. Otherwise, have a fabulous day, and go MOOC it up out there. Again, to sign off, you can just exit out of the room, or if you have questions, feel free to type those in for me.
Maggie?
Yep, hi Kay.
Hi. What program did you use this time to make the slides?
These slides are just PowerPoint.
Oh, okay. Easy enough.
Yeah.
I thought it was some super secret.
No, nothing.
Okay.
It's a specific template, and I think I changed the coloring to be a little more pleasing. I added in pictures of graphs so that I could, you know, graph things.
Yeah. Okay. Well, I haven't used PowerPoint a lot, but I'm starting to like it a lot. So thank you for the information.
Yeah. Well, and if you
See
ever
you later. Talk to you.
Yeah,
Pardon?
if you want copies of these, you know, feel free. You can just shoot me an email and I'll send it your way. That you can use as template. Yep.
Okay. Thank you. Bye-bye.
Okay. Have a fabulous day. Karen, did you have any questions? I see you're still on out there. Oh yeah, no. I'm not pushing you off. I just sometimes wonder where students are at or what they have questions on. Yeah, I think the application problems are very unique and in a wonderful way to see mathematics in the real world. Especially something, you know, more simple like this, where we're just looking at making payment plans. This is something students are very easily can hopefully connect to. I'll bring up the other application problem I didn't get to. This was a cell phone. It cost $60 a month for unlimited talk minutes and 250 text messages. And then for each additional text message, you pay 15 cents. And so then I say, well, here's a bill. How many additional text messages do you have? And there's multiple methods you can use to solve this. But again, looking at this in terms of a linear equation helps students see that they can, you know, really use mathematics out there in the real world. So I personally like the application problem.
So is X the number of texts?
Yeah. So in this case, we kind of leave this information off to model the equation. So we would say that our X would be the number of texts. And I would probably put a condition on it beyond 250, because we get 250 free ones. So when I work with my students, I'm kind of a stickler on how they define things, because how you define things is very important. And then Y would be my bill each month. And so how would you model this? And you can go ahead, if you see on the right-hand side there's a toolbar. The third tool down should look something like a pen. You can grab it and go ahead and write on the board. There you go.
Does Y equal 60?
Well, 60 is going to be in there. Yep, that's going to be the flat fee. So we'd have $60. Then we're going to have something about the additional text message rate. Okay, so we can definitely have Y equals 60, but then how are you going to add in the text message rate?
Yeah, that's where I'm getting a little confused. I'm still trying to wrap my head around this.
Oh, that's okay. That's okay. These things are a little complicated. So you would pay $60 flat, right? No matter what, you're going to pay $60.
So, okay, so 60 is that what I would do, X?
What if we look at this in terms of a table for a second, okay? No matter what, I'm going to pay $60, right? For any number of text messages, 0 to 200 and, oh, hold on, I don't want it to look like this. Sorry, scratch that. No matter what, I'm going to pay $60. Okay, and this is going to be my bill. So I'm going to pay $60, and I'm not going to pay any if I have 0 to 250 text messages. I'm not going to pay any more. But let's say I have 251 or one additional text message. Then I would pay $60 plus 15 cents for that one additional text message, or 60.15 would be my bill, $60.15. Then, let's say I have 2 text messages over, 252, right? I would be paying 15 cents each of those text messages for a total bill of $60.30. Are you seeing a pattern start now?
Yeah. So
And now, okay.
So on the left side, under X,
Yeah.
what we're going to get is the number of times, how many times it takes to get to the 3.90?
Yes, exactly. So we have $3.90 over. So we want to see how long it's going to take us to get to $63.90. Okay, but we can model this equation. $60 I'm always going to pay. But what varies is the 15 cents for every text message over 250.
Right.
So do you see each time, the way that I've kind of set this out is maybe look at exactly the 1, 2, and 3, maybe not the 0 one, but it's $60 plus 15 cents, and I'm considering 1 a number of texts beyond 250. So then I consider 2 a number of texts beyond 250. Do you see how that's going to be the variable? The variable is how many text messages I have beyond 250. Exactly.
Ah, okay. This is starting to make sense. Like that?
Good. Yes.
Oh,
And we can actually start off by calling the other side y, but then once we want to solve it, that's what you plug in for y. Exactly.
Okay.
Good.
0.15x equals 390.
Yeah.
Right?
Yeah.
And then 390 divided by 0.15.
Yeah.
Okay, let me just get out my little calculator for that.
Yeah.
390 divided by 0.15. 26?
Yep. So I had 26 text messages beyond the 250. So how many total I sent then would be 250 plus 26?
Right. 276.
276.
Ah,
There you go.
okay. Yeah, this clarifies that. Yeah, all right.
Oh yeah, these lectures are sort of giving you kind of an overview of what you're going to be seeing, and then I hope you're kind of finding in the module as we go deeper into the content.
Yeah, yeah. Okay, thanks very much.
Hey, you're welcome very much. Thanks for joining me today.
Okay, take care.
You too. Bye-bye.
Bye.